Hello, my name is Micaiah and welcome to game design number 9. We're making a game called Hamlet. We're going to be talking about, we think ads are a little too invasive, so we're going to be talking a little less about that. So it will be available in descriptions. So we're going to be talking about state machines today, most like, oh, yep. I'm like, what? It doesn't make any sense. We're just trying to make this a little bit shorter in the PowerPoint. It's going to be a lot code heavier. I, um, I really like some of the design discussions of these, but I feel like they're getting a little non-code specific. So we're going to be talking about 3 different state machines. We're going to be talking about the Brent Owens. I hope I got that right. I just did it from memory. We're going to be talking about the CodeMonkey sort of AI state machine, and then the sharp extent and specifics. And I think, yeah, so a lot of state machines, it kind of feels like it goes through this pattern. And this is kind of what we're going to be talking about. It's not an exhaustive talk on state machines. It's just kind of examining these 3 state machines I've been working on and sort of thinking about them in terms of what they're doing and which one's the best approach is kind of what I'm hoping to get out of this. But I thought, hey, it'd be fun to talk about these 3 things and share the similarities. I see a lot of connections and similarities when maybe they're not there. But anyway, so we usually start out with an idle state. A lot of state machines, they're running constantly, so you don't want to be consuming resources all the time. So you put them into an idle state until something happens. Enemies are like this a lot, where they'll, MMOs will have a NPC monster out there or whatever that's waiting for the player to come and interact with that player to attack them, and then they go in the player. Then usually goes into some sort of planning state, which is kind of the brains of the operation. I like to think about it, and then it goes into a moving operation to get to wherever they need to go, perform some action, pick up something, and then gets into the executing of that action, whatever they're trying to decide to do, and then it often repeats. Goes back to either moving to get back to the target or get back to executing. So the first one we're going to be talking about, yes, is this one. This is a Brent Owens. I've kind of I worked with this code a long time ago, and he was talking about state machines in the Goap, which is the goal-oriented action programming, I think. Oriented action planning or something. Anyways, it's basically this state machine that is a hierarchy of ways to sort of say, how to make the best decision on state machines. And there was a GDC talk recently with Torrin Adams, and he had some the Middle Earth Shadow and Mortar team on there, and they're talking about they have hundreds and hundreds of states, and that's how they control all their NPCs. And then TheHappieCat, which we won't be showing some of her code today, but she also did a sort of a extension on this the Goap system from Brent, which is sort of this paper he talked about, and I really enjoyed. But it gets really complicated in sort of how to see the states, partly because you go through these queues and hash sets, and it segregates the data out for me that it's hard to look into there and say what's going on, why is this state not happening, and we can maybe look at that a little bit later. But anyway, so then TheHappieCat sort of took the same sort of idea and made a combat system out of it, and we're sort of been combining that and building trying to see if this is going to be the state system we're going for. Anyway, so this comes down to we're kind of focusing on this piece right here, which is that the FSM is the finite state machine, which is kind of how a lot of these things are built on. They're just, really awesome. State machines in general are just really awesome in that respect, where they have, these states that are, I'm in the idle state, and then I can go to the move state or the perform action state, and then from the perform action state I can decide where to go from there. But anyways, we're focusing on this idle, move, and perform action state. I think if I go to, let's see, so right here is sort of how this this is not really anything in particular. A lot of this is sort of hashed together and completely changed around for a lot of my own purposes. Anyway, so you have this idle state. It just feeds in the finite state machine and the game object it's working on. It goes through this sort of delay action here, which is sort of like, that's actually to me is the idle state. And then down here we sort of see this create from available actions. The planner actually goes through and plans from the available actions that the state has with the world state and the goal. So it like gets the world state, gets the goal state. You can sort of see like this is like, in this Brent Owens example, he has a tool as a world state. Does the player have a tool? Do they need a tool? And then, do they have a blacksmith will create a tool if they have stone. So they also need to have stone. And then once they have and oftentimes the blacksmith doesn't have to have a tool. But anyway, so once they pick up the stone, they go to a craft station, which is part of their goal. To meet these, to meet their goal, they go to this craft station, and then they create a tool with the stone and the to create a tool, and then they go and drop it off, and then that completes the loop of the goal. Anyway, so this is kind of like, I was looking at this, is sort of thinking like this is the planning state, and it sort of takes these, and this kind of gets where it's a little complicated, because it takes these states, which is kind of, it's sort of the second, I'm not sure if I picked up on this, but then it's like the second iteration of this is it's relying on these a queue of, let's see, what is this? What would we call this? This is a stack. So it's basically a stack of states. Like you can think of plates in a restaurant, and they'll have these stacks of plates. And the first one is they'll peek, and then oftentimes we'll see that we're peeking at these states and seeing what the state, and checking out what the next state is. Like, hey, we'll peek at this state, and then we'll just get a early copy of it, and then we'll go invoke and do something on that state. Anyway, so then these are kind of hard to look at in that terms that we're so it's hard to think about that. Oh, hey, now we're trying to move to perform action state, or we're trying to move to a different state. So these get a little bit complicated, but they're really nice in the stack that the goal-oriented action program sort of gives people a world state with goals. And I was thinking about, we're going to add in some sort of, we need to have sleep states, we need to have rest and food and all these other sort of requirements for the characters and NPCs to go do, and then they'll go out and plan what's the best course of action to accomplish their goal. And part of that too is I want to create this this idea where they have to decide what's the best way to make money in the game. Like, is farming a good way to, they need to feed themselves, and food's kind of expensive, so they could go out and farm, make some money for themselves, and make a ton of food, and make money that way. And then eventually, like, if the food, has a bad harvest or something, then they're going to have to go plan out what they want to do, maybe break into other things. So anyway, so that's kind of it's just looking at this sort of idle state here. And sort of this creation of this state is through this. This is oh, sorry, I can't remember the name of this code right. Anyways, it's a specific type of code that we're just creating this action sort of type of code. It's inline function that this function is going to take in these two parameters. A delegate, I guess in this case, is what they're calling them, but Quill kind of was talking about the different ways. But anyway, so it's just delegate action. It sort of sets up this pre-function, and then it runs this function as this is the function it runs, which is kind of interesting. I've actually got it working a little bit better. Maybe I should have showed you a demo of all this working, but it just felt a little complicated. So anyways, that was the Brent Owens sort of the goal-oriented action program with the state machines that were sort of the finite state machines that sort of had these different, they combine the idle and planning, and then they have this moving, the actual, labor, I think, well, we can just look at this generic one that we have here, but they have let's see, where's the move agent? So they have this idea that, hey, and this kind of, I changed this a little bit, but they're the ones that say, hey, the finite state machine says, hey, I need to plan this out. This is what I want to do, and here's the next action, and then go out and figure out how to get to that action. And then the the agent at this point, or it's not like a nav mesh agent, but it's sort of an agent as the agent of the machine, as in the Matrix or something. He's going to go out and try to figure out how to get to his destination through this simple move command, which is kind of like, there's a lot of still repetition of this. Like there's a talk I was watching about ECS, and they're like, oh man, now you got this positional data and you only need to write it once. And you're like, I mean, it's sort of true. You just got this, you need two positions where you're trying to get from and where you're trying to get to. And sort of and you also need a speed as well. He was like, you don't need speed. And I mean, he's talking about rotations. You don't need speed, but I mean, you need a rotation speed as well. But anyways, that's sort of this idea now that we just need a speed, a time, a position, and two positions from where you want to go from and go to. And that's sort of like a fallacy of this system, even in this really simple example. This is why these are virtuals, and they're sort of build this base class here, which is kind of like, it just sits on a mono behavior and is a Goap, which is sort of an interface to what the Goap is expecting, and the agent is sort of running the FSM, and then this is all the move speed and distance, and the backpack sort of carries, and here's their well, this is not the log, but there's their, anyways. So yeah, so that's a pretty good, pretty quick. Really, I really suggest Brent Owens has a paper on this, and then I sort of have done a couple videos, I don't think on this channel, but a different channel. I did a really awesome video on explaining how we did that. And then TheHappieCat also does a combat system with the Brent Owens system as well. So I think it's just really awesome. And I've been, wanting to, resurrect and sort of relook at that and see, now that we're getting into more complex behavior. So the next thing we're going to be looking at is the CodeMonkey. Now this is the Athos. Let's see, where's the... Yeah, so here we go. CodeMonkey actually put out like an RTS game. He has these, it's sort of thinking of it like it's not a Goap system, but it's sort of like this different sort of system. But our goals, back here is kind of thinking about this idle state, the planning state, the moving state, executing, and somehow repeating that. That's kind of what we're sort of focusing on here. So this unit was just, it's just, this is how I implemented it with, most of this is kind of not important. It has that agent or character, an agent and the agent, the GOP agent in that case was the, I think they're actually, my bad. Sorry, let me look at this real quick. The agent is actually not the agent in this case. It's the labor is the agent in this example, or the unit or something. The agent is just the Goap agent, like what's running in the background, and the labor is actually the unit in this case right here. It decides how it moves. And that's sort of the same idea here, is that we have this unit or labor that has actions to tell it how to move, and then it sets up these states. And this task state is just simply, we've got this waiting, executing, moving, planning, wandering, and exhausted are the states I've come up with. You could probably maybe switch this to, waiting is kind of what a lot of people talk about, but I kind of want to standardize this, so I might switch this all to idle at some point, just like that, and then just sort of, you double click and then Control R. Control R, and then you just rename everything at once, and it's awesome. And that's why I love, someone was talking to someone and I was like, how many, you can see, I don't want to show all of these, but you can see how this is an entire, let's see if we can go to the bottom here. 500 lines, just almost 250 state machines, and various are enums. Anyway, so this is just that sort of same idea here. Over here we have this idle planning, moving, executing, and then we also have this idea that you could be exhausted, and wandering is sort of some of the ideas that I was thinking about here. Anyway, so then we also have this that has these various states that it sets up, this is all kind of his. We sort of have adjusted it quite a bit, just in thinking about what we're trying to do with using energy and various things. But you can sort of see now that they have this, right now, it's like this idea that on the tick is sort of, has this idea every time you tick the game, you run a piece of logic on the code, and that's, through the iteration of all the characters or whatever you're doing, Anyway, so we get down to this idle, which is just goes down to this waiting state. And this is actually a little bit more interesting because these are delegates or pieces of thing that you can think about. And this is a little bit more. This it'd be almost the same thing as just saying idle state equal. How is that equals this? Let me look at that code again, just to. Oh no, this one. No, come on. No, it's definitely okay. So down here at the yeah, so you could this is how I was thinking of is just sort of you can think about this that same sort of way is that we have this function that's just this that doesn't have any parameters right here, and then you wouldn't build this like that, but then that's kind of what it sort of looks like. And I think you could say var idle state or something like that. Yeah. Anyway, so that's a similar idea, but then you run like this logic into here, and then you got this sort of same idea. It's probably not compound for some. Yeah, I don't think you can. Okay. Oh, I see. Delicate, maybe. Anyways, you sort of get the idea. It's sort of this is sort of this idle state or waiting state, and then we just do this tick, wait tick, and this is just sort of talking about this idea that we are waiting. This is sort of like to keep the game moving. It like runs to this tick, runs the chick, millisecond, it's done, it moves on, and then goes to the next person. And then if excuse me, sorry about the cough there. If it goes less than a certain amount, then it sort of switches, and this explicitly switches out of that idle state instead of creating this entire idle state, and goes into the planning state, and then comes down to here. Which I think is right here is just like this planning. This is really awesome on these virtual voids tick planning, and then we see that we have these iterations of these gather, player, worker, complex, and then these various ideas of how to implement that. And that's sort of the same way with Brent was trying to do, which we're now trying to get away from, is this idea that we have, you can sort of see like a blacksmith, for instance, right here under his labors. And you have all these ideas that you have these 5 different labors, and they implement the character or unit sort of code we've been talking about a little bit. But then you also look at all his actions up here, and you have all these drop off, pick up, and then it's like you drop off firewood, pick up firewood, or you drop off stone, pick up stone, you drop off tools and pick up tools. And that's one of the things that I was really working hard on getting past, because it's like, for me, it's like that doesn't seem like a really good productive use of time to create, hundreds and hundreds of these, pieces of code that basically say the exact same thing except for a few key variables. And then sort of the same way over here is that we're working with this system is like you're still, but the core takeaway from here is this sort of idea of this is a state machine, and the fact that it's sort of it's like they're using these enumerations as the states, and then they're changing the states based on, based on, like if we're done waiting, if we're done moving or waiting, when we switched it, like I wanted to go to more wait. If we're done waiting, the 3 ticks or whatever it is that we're going to wait for, then we switch into this planning state, which is sort of it's nice in that fact. I was also thinking about this sort of the holistic 3D also had a way to show the finite state machine in the animation controller, which is actually, I thought about a little bit, because the animation controller gives you a visual, like there's a lot of people that are very visual about what they're looking at, which is great too. So it's like it shows you the states you can be in, and it's like it's in that idle state, running the animation time. And all of a sudden then it's like, hey, it's now ready to plan. So then it goes into the planning node, which you can kind of think a little bit about. and does that and that's sort of that. So that's kind of that general idea as we're talking about this idea of this waiting idle. How do we get from state to state? What does the code look like? What are we thinking about in this sort of things? I think we probably don't do we don't do a lot of like the executing is kind of really a big deal in this. Like the gathering is saying, well, if the unit's carrying something, then they switch to the plant. If they're not carrying anything and the harvest is null, then they switch out of planning because they're no longer, they just dropped off something, so they need to go back to planning, or they could maybe go back to idle. That's another thing, is like a lot of the system could maybe just go back to idle, and sort of that would sort of wait, and then that would go into planning. But planning's not horrible. Anyways, and then we run through all the the distance checks, and we do all these sort of things on the Brent Owens system as well. Over here on the perform action, let's see, there's the perform action, right? Let's see, where is perform? Let's see, there's the action state, but then I'm looking for the performed. Maybe it's actually part of the labor. No, here, let me not go to that one. Let's go to a lesser, easier one to manage. But yeah, so here's that sort of same thing, but well, a lot of this is sort of the check distances and sort of the perform action, but I thought there was a way to say, yeah, okay, sorry, it's right here. See, this is sort of that. I think this state does way too much. The perform action state does way too much, and that's actually why you can sort of see this work state as well. But we come down here, and then once we get into this check distance state, and then we check the is range and is done, and then we start doing a lot of, then once we're in range of the action, then we perform the action. So that's one thing I really appreciated about the talk from GDC with Tarn and a lot of other people, is one of the things they said is keep your states very, and that's sort of one aspect of why you'd want to break them down into these very minute states. But I think there's a sort of it can be too simple, and it's like you're sort of like I've had to edit these scenes so much because I wanted to add to a knit, which is sort of, and it's the tool, and sort of has tool, and it's like I have to go through every single one of these, and then it's like you change a single thing in here, and then you got to change everything back into the thing. So anyway, so that's sort of the idea of this is the CodeMonkeys. He has these finite state machine using a switch, using a enumeration of the states, and he has that switching, and then that runs code based on what state he's in. The idle state we saw there, and it's nice that he actually separates out. It's not to say that the GOP with Brent Owens isn't good because he's not splitting his states apart. That's easily possible. It's just how he just sort of designed this simple idea at first, and then as you expand it, you sort of want to do, a little bit more. Sort of, proceed, checking, sort of plan, part of planning. And that's too, it's like what's part of planning is sort of that moving, sort of the distances are part of the moving. Anyways, so then he, once he plans it out, then he starts moving, gets into executing, and then he goes back into planning, and then just kind of repeat. That's kind of what the final thing is, repeat. So the final thing we're going to be talking about is the sharp accent. Let's look at our time and see if I'm, oh yeah, 23. It's going to be quite a, sorry. This problem with these code, well, there was a code centric, and then sort of trying to put a lot of ideas. Is you got this is from the turn-based machine, or turn-based, sort of the new turn-based from Sharp Extent on his website. So here's, he's got this session manager, which is sort of handling the player session data, and then he has these interactions, which I think are, all states right here. So these are like, these are broken down into sort of what the game is doing at that time. So the interaction states will have the input manager, the detect. These are some of my own names as well. He has this handle mouse, and I call it detect mouse. Anyway, so it's a lot of this is sort of Um, the idea here is to show, that he's breaking these states down into these core state abilities that we have. This is the interaction state. It's a whole branch of the entire. And he's actually switching the entire game over to this brand new state of things that's has like you have your input manager, your detect mouse, and your move camera, all based on this interaction mode, and then you go into this other state, which is the look at, or rotate to direction, or these executing states, sort of, and then he sets up these all states as like all the states that can be happening here, which is kind of nice because it sort of gives you a huge list of all the states you can do, and then that's sort of what the Goap is for. It gives you a list of all the actions you can do, and then it plans out based on the cost of those actions to give you a thing. This one sort of, when you click on a character, then it goes into, you're into this, you're looking at the interactions, or you're looking at the ability to interact with the world, or you click on a character and then sort of right click, then you get into this navigation path where it's like you can just, you're navigating, you're trying to decide where your character wants to go. So it switches all the character interactions and the camera sets, and goes into this move state of the game. So he's like, but in its base form, it's still the same sort of idea here. Let's see if we can look at. So we look at some of the state. Is it still has the tick, or the executing action, executing idea. Do we have a? I guess we should have prepared a better. Yeah, you can sort of see, like, I was looking at this. Is this this weight? I haven't started this a long time ago, and I've sort of been picking it back up again. But this wait state, is that sort of the idle state? That's kind of one of the things I've been looking at. Is this the actual sort of? It probably is, most likely, is sort of that idle state. And I'm not sure what the best case to show. How to get into a lot of this. I've been messing with a lot of and then a lot of these are, you sort of set the actions, and these are like I was looking at, these are kind of like the GOP actions where you have these bits of code. This is like just a very generic. You don't want to look at a character, so it checks. You have to say, is the action valid? You check on the tick of the action, and then you do the action. It's sort of like that, the planning and the prep for it, and then you do the action. And then some of this is not. I think this, and then yeah. So, and a lot of this is just sort of that. Here's this set of the GOP. We're getting more into the GOP actions instead of these idle states. But it's sort of this idea that we have the start of the state and the stop of the state, which is he's getting away from a little bit. But it's still, you have this sort of same idea. It's like, and that's what he was talking about. He has state machines running state machines that are doing state machines. That's crazy, which is awesome. And it's a little hard to sort of express that in this video. But it's sort of this, not that it's, there's no right or wrong way about doing all this. And this is sort of my take on this. Let me. I don't think there's a good way to sort of suggest how to. How to find. I don't think this is actually being used as much as I was messing with this a little while ago. That we have this. Yeah, so like when you run out action points, you set the state to the wait state. And that's just often it. Like the wait state isn't actually that big of a deal. As much as I'm trying to. This was the focus of the talk. Or, the discussion here was this, but the wait state is actually really just that. It's just a basic generic wait state that runs the state commands, which is just runs the tick. So we're just waiting, just ticking every time, and we're executing the code, and then this is run through this the tick of the session manager, which is sort of running the tick of the current state. So the current state is just waiting, and all it's doing is just ticking down. It's like, hey, I acknowledge you're waiting for me. I don't know what's happening. I'm waiting for things to change. And then when that thing changes right here, then we say, okay, we want to switch to the wait state, or we want to switch to this interaction state, and that's sort of like this idea that this state machine is just, it doesn't care what's happening. It just knows that it's currently in this wait stating, and it's just, every time it runs the tick of the update of the game loop, it just says, hey, I'm ticking, and then this, it just runs the basic state command of tick, which is just, hey, we're not exiting, we're just sort of executing, and I don't think there's any actions on the state because we haven't set anything up through the session, the player state manager. We have, like this one, the actions of this is move character and rotate character and do these things, but we haven't done anything like that. So we're just sort of, the game is waiting for things to happen, the user to click some other state machine to tell the current action state that it needs to switch to it. So anyway, so that's kind of the core of this discussion. You could sort of see Sharp Extent still goes with that same sort of idle state, goes with the planning, the pre-checking, the checking distances with the moving, and executing. I think this is like move character on path. It's like this. It sort of does this sort of thing where it does have this. It's just basically trying to set up these characters and check all their position and make sure everything's ready to go, and then it sort of gives you this points. And well, this is actually the move character, but the actual entire state is this navigation. Let's see, well, I think that's all. I think this is actually just a state that the game can, the game as a whole is you select a character, then tell them where to move, and then that sets it into this navigation on path, which it has once it finds the path. But anyway, so it's like you still get this sort of same idea. You have this idle planning, moving, executing, and then you repeat back, and that's sort of one aspect of this, navigation on path, and then you have this other state machine running the selecting character, and then you have this other state machine running the entire game. So it's pretty cool. The kind of the thing for me is down in here. Let's see, on these the Goap agent, to get away from this sort of. It's not that these are complicated, but sort of maybe I should break these down a little bit more so they're not, adding in more states here. I think and then sort of getting out of this idea of just popping and pushing states. This seems like a bad, for me it's really cool, but when we're sort of, when we're running 3 states, it doesn't seem that bad, but when we're running hundreds and hundreds of states, we sort of need to sort of have more. And then also sort of break down, let's see, where is the, I think, is that the planning? I'm trying to think of when is there a move state? Once you create the state, I thought there was something I guess just sort of setting these states based on, I was kind of wondering if there's a way that it was setting. Oh yeah, I guess it's, so it's just, oh okay, so I guess it's, so it's these are the actual saved variables up here. So it wouldn't be bad, I guess, to create all these, create, and then you can actually create another public FSM state, plan state, plans what to do next. So that's sort of like, and then you can create a whole bunch of states, and then, but a lot of this is like you want to keep this down almost to this sort of idea of we're just these basic core functionality, and then that's, this isn't going to change that much once that sort of gets set, and maybe it doesn't even need to change away from the, oh no, I'm sorry, we're back down, I guess we moved away from the code, but it doesn't need, this Goap agent doesn't need to change that much because it just needs to know the various states, and then they're all just basically actions, and you can sort of think about these actions as sort of these same actions over here in the session in the player state, in the player state manager, we have these sort of same actions right here. Is that we have, I think we actually do call something called action. The attack actions for other things, but well, I think these are, these are state actions, I guess. So these are actually all just the abstract of this idea of states. So you could just see that there's sort of the state actions, or just like a GOP action that is going to say, hey, This is all sort of how to get the action in place, but there's, you get down to this action over here, and it basically says the same thing, that you want to run the action. Like right here is just the perform. So this just gives you the perform of the action, which is just the abstract of, hey, we just have to be in range, which I think is just, yeah, I think there is an in range check, and I've been messing with a lot of this. So anyway, so that's kind of just the general idea of just looking at this. Hopefully I maybe have confused myself a little bit more, but I'm trying to figure out what is a good way to sort of get into these states. That we have these this is all actually part of the planning of the states, which you still kind of have to do, and the in the let's see, oh yeah, in the CodeMonkey one, you still have to sort of figure out how to get from one state to the next, which is sort of maybe this, looking at a bigger example of this through the gather state. You still have to figure out how to get from, where you're at, right here. Well, this is all part of the setup. So this is like, where you're sort of saying, hey, once I've done all these stuff, it should eventually come back and say, well, eventually it should go back into a different state, which you can sort of eventually. Yes, you can see here is like the state task is set back to a different task. Once the animation is complete, it goes back to a different task at some point. On the task arrived, or whatever. It sort of gives you a different. Is there a task arrived? Oh yeah. So here's the once it arrives somewhere, it resets the state back to executing. And then it says, hey, I no longer. Or once it's moving, yeah. See, once it's moving, it sort of does this tick moving, which is part of this. That's part of that. But anyway, so once it's sort of, that's sort of it. It's like it's just waiting for. It's just ticking down, saying, "Hey, I'm moving, I'm moving, I'm moving," and then the character is like, "Well, okay, give me your distance." And as soon as your distance gets within that good distance, then it executes that state. So it's like the character doesn't know, how to get to that executing state. It just knows that right now it needs to go to that moving. It's moving that state, and then another state machine sort of says, how to get to that. And I like this system. I always like this system a little bit cleaner, where it's like we're sort of doing, it's like it's a little bit more straightforward about, using enumerations, which are my favorite things to use, and then we can add in more. This idea was, wandering was sort of this idea that the unit was going to wander around randomly. So it was going to move, it was going to start saying, hey, I'm wandering, so it's going to pick a random spot and go wander to there, and then, sort of do that, which was the intention. But it just sort of folded into idle for a little while until we got that working. But, I mean, it's just an idea of, copying sort of this, let's see, copying one of these states that say, hey, move here, and then just picking a random spot, So, and that's sort of what the cool thing about this is, that you could just say, hey, public virtual void. It's probably not how I'd want to do it, but it's sort of just this simple idea that, pick a random spot close by to move to, and then that's it. And then it's like you have this whole new state. It's not kind of how you'd want to do it, but it's just, for the purpose, you would have to actually, I think this is actually just, we are moving towards that something. I think this is sort of like a more like we are moving aimlessly. And then it's just ticking off of that, which is what this is actually meaning. I think the actual character would actually implement this, sort of this better through here. I think you would implement, maybe tech's not a good word, but this is sort of task, or I think that's part of it. It's just like, this is like a, yeah. Anyway, so that's just hopefully trying to get a good discussion on that. Probably have gone way too long in this video now. Oh, almost 40 minutes. But the idea is just basically that there's state machines out there. They're really cool. They can be very simple state machines. They can be state machines that interact with other, like goat planning. The goat planning is sort of planning out what you're going to do, and based on the cost of everything, and run that. Here, let me actually show you Brent's. I think Brent's is cool. Not and a lot of these are also cool, but they're not. I haven't gotten a lot of them. I haven't got a lot. They're in various working states, but Brent's, since his was, I actually a couple days because I lost some of this code. But you have this idea of, excuse me, of just this. You have this pre-generated world of his. We can actually just run this right now. He has this little pre-generated world. I've added. I think I'm selected on character. That's why I couldn't move. You have this logger. He's going out, and he logs wood. He drops off the wood, and then he picks up a new tool. And then right now the balance is a little bit off. When he logs, he breaks the tool, and then he drops off this. And then eventually, like that guy had to go over here, and that's what yellow's going to do as well, the logger, because there's no longer tools. And that's the same with the woodcutter. But the blacksmith, there's actually, I think, like preset of 10, 12 tools here. The blacksmith is actually collecting making the tools using stone, and eventually he'll run out of stone here, and he'll have to come here. And then eventually they could just drop off. I think he'll drop off his stone here because it's the closest. But then he'll go up here to pick up a tool. So he's deciding all that is on his own based on the state machine. He's running an entire state machine, and I think there isn't any. I don't think there's any code that says we have a lot of. Let's see. I don't think there's actually any. Yeah, there's no actual game management code, I think, running as far as. Oh, sorry for the cat. There isn't really a lot of game management code running. And the other thing about this is that we hear. Here, I'll probably wrap this up because she's probably going to get really loud. Anyway, so you can sort of see here is sort of the same idea, but it's sort of everything has been randomly generated. And then we've got these canvases that are not quite working yet. But then this is our now generic logger or generic harvester, and he hasn't quite figured out that he needs to go. I haven't figured out why he doesn't, go do things, but he should sort of do. He has the components he needs on the trees, which is kind of really simple. It's not even just anything interesting on the resources. You can look at the tree. We just have this tree component, which is the original one, and then this harvest component saying, "Hey, I'm a log," and then it just sort of has these. They're meant to be canvases, but they're just poorly drawn right now. Which are meant to like health bars and stuff like that, but that's sort of I haven't really messed with that in a while, but yeah. So hopefully, and then you can sort of see the aspect of this is like 2D right here, but what if it was 3D? And I've done that before, and I want to start getting that back up and running, but I also want to start adding in more complex behavior, such as needing food, creating food, and start building bigger and bigger. Because if it was good in Shadow of Mordor. Middle Earth Shadow of Mordor, as he was required to say, but didn't. It should be a lot more. It should be a lot. Hopefully we get a lot more execution out of this, and we'll have to. That's kind of we'll have to see. I'll have to play a little bit more with some of these systems, fix the Goap sort of procedural generated system working with. I need to do it that way because I need to have. I want to have hundreds of jobs and hundreds of different types of people, and I don't want to have to create thousands of different code files. I want to just create generic ideas for it, and then maybe split that off later into, maybe 2 or 3, Like, for instance, one of the things I have now is I've sort of already split off is I have this idea that the characters move with the laborer, and the laborer doesn't care how to move. It doesn't even know that it can move. So it's another system that I have in place. So I need to split that off. Anyways, and I think have I misspelled executing? I probably have. I just typed it out real quick. Oh yeah, extra C in there. You see it whines, but it doesn't want to do. Oh, there we go. Yeah, and then it whines about idle state. Well, what can I tell you, buddy? Here, Oh, you didn't even put a little there. Idle state is it's actually more like that. Or, excuse me. Anyways, this video is quite long, so I hope everybody can appreciate the, even though I make spelling mistakes and often and problems that we've talked about a lot of these really cool systems. We're hopefully a little bit more code heavier, and we'll see where the next goes. The game design. I really enjoy these because it sort of feels like it gets me to sort of decompress and think about what I've been working on and what system I want to sort of work on next. But anyways, you can leave a comment in the video and say, man, these videos are way too long. I can understand. My name is Micaiah. Thanks very much for checking out the design, and we'll see you next time. You take care.